we're still relatively very unknown because of the stage we're at. And this will both increase our visibility. It's also happening at a great valuation. And also it will, we want them to be aligned with us in what we're trying to do, because we think that works very well, both in terms of objectives and psychology.
$1 million question. So why should investors now feel confident about investing in a company like Phi?
They'd be crazy not to. After all we've said.
Hi, Stefane. Hi, Tassos.
Hello, Panagiotis.
It's a pleasure to finally meet you in person as well. We've been talking a lot of time via emails and phone calls and video calls. It's good to finally see your faces. We have a lot to discuss, and our investors would like to know more about you as people, as the people spearheading Phi, an exciting new startup. So to start off, I'd like you to briefly share some details about your background and how did you come to the field of CAD, computer-aided design, and software engineering, because you both have this background. So we'd like to know like a little bit about your background.
Sure. Thank you, Panagiotis. It's lovely to meet you too. And it's great to be here in Cyprus. And thank you for the opportunity to talk about Phi. It's our passion. And we love doing that. So, well, software engineering. I've always wanted to do that since I remember myself. I loved playing with computers, early versions that I won't reveal now because I'm afraid it will show my age. And that led me to a degree in software engineering at Imperial College in London. And that's where I met Stephanos and our third partner, Vasilis Kapouleas, who's not here with us. He's the crazy mathematician. And we first became friends there. And through this, we focused our interest on highly complex algorithmic design. And the field of CAD was very much in fashion then and very interesting. And it instantly attracted us. And that's how we started. And
I'm also a total geek since teenage years. And as Tassos said, we met at Imperial College. I'm a couple of years younger, so I had to complete my studies in the States after we left Imperial. But we had already started discussing about this passion in software engineering and computer-aided design as an application area, which was very interesting because it was in deep need of some new developments. And so in returning from my studies in the States, we hooked up again and we started our first common venture in the field of computer-aided design.
Right. Nice. Excellent. So you are very well set up for a product like Phi, which I'd like to discuss a little bit more now. For people who may not know what Phi is, what is Phi? How does it work?
Right. So Phi is a software application that runs on the browser. It's cloud-based, fully cloud-based. And it's what it does is it's a computer-aided design application, CAD application, and it does beautiful things in surface modeling. That is in the design of models that are free-form, have organic shape, free-flowing surfaces and curves, which is pretty much everything that's that's around there. It's a big part of what's being designed and produced, and its target users are concept designers, industrial designers, product designers. And
interesting. So we'll also delve a little bit more into that later. But what would you say briefly separates Phi from other CAD softwares?
Yeah. So most design, for example, product design, industrial design, and in fact, most products that we see around us consist of some parts which are more rectilinear or simple to describe, but also some areas which are more and more described by what Tassos mentioned as free-form, free-flowing surfaces. And it turns out that this part of the design is the most difficult and time-consuming. So there are various applications out there, of course, where designers currently can do pretty much all of their design work. But what Phi brings that makes a big difference is that the part of the design that has to do with these difficult surfaces, we can do faster, without losing any precision, and in a very natural and intuitive way. We call this the edge-based design paradigm. So basically, we allow the designer to work very fast, in almost in the way they would do with pen and paper.
Excellent stuff.
In a nutshell.
Impressive. I'd like to know more about that later. So you two met at college at Imperial in London. Vasilis also was...
Yes, he was.
All right, perfect. So
Vasilis did computer science there, and then he followed with a PhD and postdocs in computational geometry and in the theoretical and mathematical field. That
great. So what inspired the team to start Phi?
Okay, so I'll have to go back to what we were saying before about when we started working together. So we did start very early on, many years ago, working in CAD in a previous incarnation before Phi, and we worked in that process. We were very lucky because we worked with some of the biggest companies in Europe and the United States, CAD software companies, SolidWorks, Tassos Systems, or other US companies. And we had a very close cooperation with them. We developed component software which was for geometric constraint solving, again based on our own R&D and proprietary mathematics. And through this experience and working with the experts and seeing the users and all the problems they had, surfacing was a huge problem. That there was this big gaping need for software that does what we hope Phi is doing now, and will be doing too. That's how we started seeing that there. So when our other work reached its end cycle, that's the first thing that we wanted to do. It was because we felt we had gathered the experience. And that we had the tools and everything ready to be able to attack this big problem, which, by the way, the market had it for many years, and everyone wanted to do it, but it was super hard to do.
Now you're ready.
Yes.
So it was the realization that, okay, now we are ready and we have everything we need to go out there in the trenches.
Exactly.
And develop like this new software and solve all of these problems that these designers face in their everyday work.
Yes.
Yeah.
If not all of the problems, the main problems.
Okay.
Yes.
Yeah.
And we were lucky to complete the research side that we developed with real world industry feedback. We saw the need in the market through these big companies that we worked with throughout many years. So it was clear that we were after a problem that was not just our own theoretical passion, but a real need to be filled in the market. And that's how it started.
Great.
And by a market that's very demanding, and it's a high end too with the surfacing. So
All right, so let's talk a little bit about how you tackle these problems. So my knowledge in this field is quite limited, as I assume it would be limited for many of our listeners. So you've developed new mathematics to tackle some of these problems. So what are these new mathematics that you've developed, and what problems do they solve for the end user?
Right. Okay, so I'll start with the problems. The fundamental problems were, and still are, and that Phi comes to solve are, that it's still very difficult and time-consuming to design anything with organic shapes, those free-form surfaces, those flowing shapes. And by the way, if you go to Google and just a search engine and type product design, the vast majority of what will come up will have some kind of these surfaces.
Okay.
So it's very time consuming. It often requires a degree in analytical geometry.
All right.
It requires very many iterations. It requires often for the designer to have kind of traced beforehand in their mind how to go about their design, not what their design is going to be, but how to, let's say, fight the underlying infrastructure so they don't fall in on a mine, let's say, and blow up, because then they have to start from scratch. Yeah. Okay. You very often have to throw everything away, right? So, of course, you can design, as Stephanos said, you can design fantastic surfaces, but with how much pain,
time consuming,
and
it takes a lot of resources as well.
To give you an example, in the traditional way that people design now, which is a technology called NURBS surfaces, right? One traditional way of working is that you don't start with a 3D model. You start with 2D profiles, that is like cross sections of your model. So you imagine how these are going to be. You start drawing them, then you start trying to fit 3D curves through those profiles. You're not seeing anything in 3D all this time, right? You hope that they will match, and then you do something called lofting to generate something that is a surface that you can see, and then if you want to do any changes, it's very, very difficult. Often you have to start from scratch if they're non-trivial, and so on.
Okay.
Right? So this is not a way that people want to work, right?
Understood.
There have been other approaches to try and alleviate this pain, like subdivision surfaces, which came from animation, from the field of animation, to try and answer this. And they have, to a large extent, managed to bring ease of use to surface modeling, but they have other limitations.
Okay, such as?
Yes, for example, you cannot directly control your model. You do not, like in Phi, you pull the curves, right? As Stefan said, curve-based modeling, you pull the curves. It's like a magic push and pull, and you have the surfaces. They're filled in automatically by Phi, right? Top quality surfaces with smoothness where you want it.
So what you're describing right now,
that is Phi.
is what these mathematics allow you to do.
Yes.
Okay.
Whereas in subdivision, you do not actually pull the model. You have something called a cage, and from this, the model is inferred. So that it's indirect. You cannot dimension it. You cannot finally control it. After a few iterations, it starts having problems. So it has other issues.
Right.
So Phi had to solve these problems. In order to do this, we had to build the new mathematics and algorithms. It's not that we did it for fun and then tried to find an application area. So this was, the most difficult part, because this is deep tech. We had to work for years to produce this.
So this was the job of the crazy mathematician, Vasilis, mostly?
This was fun. The core of it was, but we also use actually... we use software development as a tool for mathematical research.
All right.
And that's for a different podcast, maybe, but it's actually fascinating. Not necessarily for mathematical research that one would want to publish, but for the kind of mathematical research that is required for the industry. So we develop a lot of software to test the mathematics, rather than have Vasilis sit on an island for 15 years trying to prove that it works.
Yeah. So I've heard a lot these free-form and curve-based designs. What exactly does that mean? What exactly is freeform?
Right. So if you think of any product, it can consist of shapes that are flat, or shapes that are not flat but have certain characteristics that are very recognizable, like can be a cylinder, a part of a sphere, or a combination of those.
Geometrical shapes.
Exactly, geometrical shapes. So freeform, I would describe something that cannot be created by taking these standard geometrical shapes and combining them.
Okay.
So a surface that is like a wave, for example, you cannot take a cylinder or 2 or 3 cylinders and put them together and try to create that. So you need to start in a very different way. And this surface cannot be described by some simple geometric equation, like points that lie at a certain distance from a center or an axis or something like that. It's a completely different animal. And to handle this, you can either go and do it with traditional mathematical approaches like NURBS or SubD, or you can use this new mathematical infrastructure that we created.
Perfect.
And you can think of any Nike shoe, for example, which directly the shape is very, very complex and fluid and freeform, things like that.
Excellent. So correct me if I'm wrong, but as far as I'm aware, many of the current solutions that are out there in the market are locally based, offline, where a designer sits on their laptop, they spend hours on the design, they want to share it and collaborate on the design with their coworker, and what they have to do is take a USB, put it in the laptop, take the design, put it in the USB, take the USB, get it to the other laptop, and then the other designer can start working on it. As I understand, Phi is fully cloud-based.
Yes, you're absolutely
let's
right,
expand on that.
You're absolutely right. In fact, it's even worse than that. You have differences with versions in other software.
It's very surprising.
It is, isn't
it? That this industry in this day and age still works in that way.
Yes, yes, with all those users, and the vast majority of them still work the way you described.
Okay, so how
with
difficult is
incompatibilities between versions, with things running on just on one platform, with people trying to work together and not being able to for the reasons you described. In fact, in many other ways, it's the same. And that what we described before, for example, like the push-pull direct modeling facility that we described that Phi has, if someone is not in the field, they might, again, we've had this lots of times, they will think, so what's so special about that? Can't software do that? It's just push and pull. Come on, guys, we have a mouse. And it's really, it takes a while to try and explain that, no, actually, it's like this Paleolithic monster.
Exactly. So it's surprising because how difficult is it to develop this feature, this solution, this product to be on the cloud? Like, how difficult was it for you to make it fully cloud-based so that designers can collaborate in real time?
We had the advantage that we started from scratch. So we did it from scratch to be cloud-based with all the new technologies. For the older companies to do it, it would require rewriting everything.
Okay.
So it's understandable why they don't do it. And in fact, Onshape, which is one of the great CAD companies that is also our partner, we work, Phi works very well within Onshape. It works as standalone too, but it has a great collaboration in the workflow of Onshape. Their reason of being, the reason they created the company was exactly that. So it would run on the cloud with all the advantages this brings.
So that was their entire USP.
Yes, they didn't try to do anything different in terms of functionality or everything like that. In fact, they just did that.
So
and they got sold for $500 million.
Just for taking all of this and making it cloud-based.
Which is not a just, as I said, because you have to rewrite the CAD system from scratch. That's why they raised $170 million in VC funds to be able to do this, which shows you how monumental.
I completely understand. From your perspective, it's not a just. From the perspective of someone who doesn't really understand the field, it's a just.
Yes, it is a just. It is, you're right.
Yeah. So. Brilliant stuff, guys. There's a lot there. I think we've covered a lot of the things that Phi differentiates itself from other solutions out there. Is there anything else that Phi does differently from the existing software? Or I think
I would just add to the last point that being cloud-based opens a huge advantage in terms of collaboration, which is something that is very needed because very often these companies work in large groups of designers, clients, and the ability to directly, instantly share or collaborate on the same design from different geographic locations or to have your client watch as you make changes to your model is huge and very much needed. So our decision from day one to go cloud-based completely and browser-based opened us to the possibility to offer this type of work.
Good stuff. So let's turn a little bit here. One of the most important things for entrepreneurs as well is doing mistakes and learning from them. So I'd like to ask you, you did a venture before Phi together. So I'd like to ask some of the mistakes that you made in that venture and the lessons you learned from that, and how these lessons will help you now in Phi.
Right. The mistakes are very painful when they happen, but then they are very, very useful in furthering yourself and your company. And one thing I would pick from our previous work in working with these CAD companies is that because that was component software that we did, that is software that integrated at the heart of those CAD software systems. Okay. It was transparent to the user. They could ignore that we existed. It offered additional functionalities and so on and so forth. But because of that, A, we had a very limited market, which included just the CAD software companies. And B, it had a huge sales cycle.
Okay.
Because you had to integrate something very important. It's one of the two key elements of any CAD software system, right? That component. You had to, the constraint solver. You had to integrate it at the heart of the system, which required a big amount of implementation work. And you expose yourself to all kinds of possibilities of, down the line, you became dependent on usually one customer that you were servicing then because it required a lot of resources.
Yep.
And so that was a pain point as it turned out. Like when one of the collaborations we had focused so much on kind of closed its cycle, and we had to start another one. That became something that was difficult, and it wasn't ideal. And so we didn't want to do that again. We didn't want to do component software. And so because of all that we were discussing before, that we focused on the, we had seen the need for the surfacing, and we had done some work already in this direction, theoretical. We thought, no, we'll go to the end user. Yeah, we'll go directly to the end user, put this
much
in their
shorter
hands.
Sales cycle as well. Yeah, not very dependent on any single customer.
Exactly. We undertake more of the implementation because we have to build not just the core, but the whole CAD tool, the front end, the user interface, and everything that goes with it for the workflow. Yeah. But we'll put it at the hands of the end user designer, who will appreciate them, and they will see them, and they will choose the product because it allows them to model very, very quickly and very efficiently and high quality. Yeah.
Stephanos, do you want to add anything to that?
I would say something kind of similar. So also because this first company that we started so many years ago, we were basically straight out of college, and we're very enthusiastic about our product and what we created. When we attracted the attention and interest of one big company who offered us the opportunity to collaborate with them for years, so they actually funded a full development team in Greece to work on our software and integrate it with them. This basically became almost our entire reason of existing as a company. So we put all of our eggs in a basket, so to speak, which was extremely useful for us. We learned very much from this collaboration. However, as Tassos said, when this reached an end, we kind of felt we were left somehow in a void. Yeah. So, and that's why we chose in this new venture with Phi to go for a product that would be used from either a big company such as Nike or Garmin or Trek Bikes who have been using our software, down to any hobbyist, any freelancer, and so be exposed to a very wide market and not locked into one specific
perfectly case. Understood. Okay, so these are the lessons learned from the previous company that you started, and that you are applying these lessons in Phi. So my question now is, what are the biggest 1-2 challenges you faced with Phi, and what are the lessons learned from those challenges or mistakes, whatever you want to call them?
Right. Yeah. So, well, there's the technical challenge was obviously a big one, but that was something we felt comfortable with. Of course, when because Phi is deep tech, because for the reasons we discussed before, it always takes longer than you think, right? But we were fully aware that it was going to take a long time. The other lesson, let's say, it's also a lesson. It's and it's a challenge with all deep tech, but it's also a lesson learned for us through Phi this time. Is that it is never too early to start marketing and commercial efforts, even for deep tech products. Okay, obviously there's a long period until you have some kind of prototype when there's nothing to show. Obviously, you can't do any marketing then.
Yeah.
Maybe you can do some initial probing,
like focus
probing
groups
and focus
stuff.
groups,
Yeah,
yes,
yeah.
which definitely needs to be done as well.
Of course.
But
having this
that,
product out in the market is an entirely different beast. Yeah,
exactly. And of course, you need to get it out there as soon as possible, even if it's got issues, and it will have issues.
Yeah, of course. And it's understandable
launch,
by the end user, I think, in most cases.
Yes, especially if you find power users. And we did do that. We found power users. And as Stephanos was saying, it went through a lot of beta testing, 3,000 plus, 3,500 users that did beta testing and provided... They don't all provide feedback, but you know how it is. And we worked with specific designers for the product definition. But that's about it. We should have done more at an earlier stage in terms of commercialization and the marketing. So that was a challenge. Yeah. And we learned from that. And now we're at a place where, the product is, we have the MVP launched and...
it's out there.
And now it's out there, and we are gearing fully for the commercial work to go to market and take it out there. So
interesting, right? So you've touched upon like having different potential customers from end users, like single individuals, up to like huge companies.
Sure.
So how big really is this market? So what is the market size and how big can Phi potentially get?
Well, there's at least 45 million designers that are, that's an easy number from the numbers announced from the people who, and from official numbers, let's say, and groups that publish these numbers. And the market is projected to reach, I think it's $28 billion by 2030.
So that's for individual designers, this market?
It's
the entire
the CAD market.
Okay, the CAD market.
The CAD market, not just individual designers.
Understood.
There's a lot of individual designers. There's small companies, let's say, small companies that have some freelancers, and there's much bigger groups of designers. So this is the size of the current market, but we are actually aiming to address an even bigger market.
Okay.
So both in verticals that the Phi technology will allow us to go to do things that are currently either not possible or take a long time, and also allow very easy and quick customization in verticals. Let's say in the first category, there's like, for example, ship hull design, for example, or specifics of the aerospace industry. Then there's things like prosthetics and the customizations you could do there through Phi technology. But also other huge markets like the 3D printing market, additive manufacturing. And actually the Phi technology is a key enabler for that.
Right.
And not just for the professional market, which should be obvious, hopefully, from what we discussed already, but also for the makers and the hobbyists and the market that hasn't really been addressed. The revolution didn't materialize there. And we think that one fundamental reason is that there was, if you're an average 3D printer user, how can you design and manufacture something from scratch, or even just try and copy something when there are so many difficulties ahead in using the software that's available for the reasons we explained? So there's a lot of extra ticks, let's say, in what is already a very big market.
Okay, so currently the features that are developed and the stage that Phi is currently, it's playing only in the field of CAD. However, there are like thoughts of additional features and customizations that you can make to the product that can address these additional markets that you touched upon. Is that correct?
That is correct.
Okay.
They're not outside the field of CAD, but they are outside of what is now being addressed by CAD software.
Okay, understood. All right. So in terms of this CAD market, who are the key players currently in this market? What is the market dynamic like? Are there like a few big players and small and lots of small ones? How does it go?
Yeah, the market currently is dominated by 4 big players: Dassault Systèmes, Autodesk, PTC, with whom we have a close collaboration.
Okay.
PTC is the company that acquired Onshape,
Okay.
which is the fastest growing cloud-based CAD platform. And we are integrated within this platform, and we have been exposed to their users, and we have a very tight and useful collaboration. And Siemens. So these 4 players basically have a few products each out there. Some are more targeted towards traditional rectilinear, let's say, geometric design. Some have some products that are in the field of offer some solutions for freeform modeling. So there are competitors.
Yeah.
And that's the market that we are entering now.
Right.
And
there's lots. Sorry, did I interrupt? No. And there's lots of other smaller companies. Some are focused, like there's architectural CAD and so on, but there's also lots that try to gain some traction and gain some market share by capitalizing on things like new technologies like AR, VR.
Okay.
By the way, Phi is great technology for this. I didn't mention it before, but it's great. Imagine if you could have a VR set and you could push and pull your curves. And we've had users who have been asking for that for a long time.
I can imagine,
so there's some startups there too who are trying to make.
There are lots of other startups that maybe Phi, maybe not, maybe in some regards, maybe in some other regards.
Things, they do different things.
Okay, so sounds good. So do these like big players in the market, are they like potential acquisition partners, would you say, for a potential like exit for Phi? Through these 4 players?
Absolutely. And we've seen various cases of companies that have been acquired. Just mentioned Onshape with PTC, and our technology we feel would be very interesting.
Okay.
Also for them. So yes, totally.
Yeah.
So
because it's not a marginal nice to have surfacing.
Yeah.
It's if you want to be a serious CAD software package, surfacing is a huge thing. You have to have great surfacing.
So besides these 4 players, are there like any other potential big players in other markets that could be interested in acquiring a company like Phi?
I would say definitely, yes, most definitely. I'll give you an example, Panayoti. Do you remember the Figma and Adobe?
Yeah.
Right? Adobe offered $20 billion to buy Figma. And it's... Phi is like Figma in 3D.
Yeah.
Right? Okay. The analogy will only take you that far, but it is like Figma in 3D. And in fact, in other ways too, because they went through a big stealth phase, let's say, where no one knew about them, and they did years and years and years of development until they launched, and then, gradually, and then they took off. So Adobe is already moving into the 3D space. It's got software for that. It was very interested in Figma. And it's an example of a company that might well be, a kind of company. I'm not saying Adobe specifically.
Of course.
Would be interested.
Yeah.
And also,
companies that are in the field of 3D printing, like HP, for example. As Tassos said, our software would be ideal for enabling the increased use of 3D printing. So they might very well be interested in getting hold of it and maybe packaging it within their printers or something like that.
Interesting. That's very good news for investors, that there are a lot of potential acquisition partners.
The gaming industry. The Phi has, some of our users are game designers. And we've heard things that actually we didn't expect, to be honest. We thought there was more of a target in the things that are manufacturable and high quality. And we had feedback like, I can design in Phi nothing else.
Whatever character I want, or like shape and houses.
To the extent that we almost questioned them, why? Why can't you do that? It sounds silly, but we didn't expect it. And so, there are lots and lots of
interesting
open paths.
So let's turn our attention now a little bit towards the fundraising and the financial aspect. So you've raised $1 million from Big Pie in 2019, and a further $1 million again as a follow-on investment from Big Pie in 2022. So what have you used those funds for? What have you achieved with those funds so far?
Yeah. So, well, we've done a lot, I would say. First of all, the actual deep tech research that we described to get to a point where we had the mathematics, the algorithms, everything we needed in place. Then we packaged all of that into a product, gave it the characteristics that it needed to have to run on the cloud and in the browser. So the technologies required on the server side. Then we integrated with Onshape, as I mentioned. We hooked up to their API, and we have a very fast and seamless collaboration. So you can bring in, send out models, etc. And that allowed us to open up our platform to their users, the first batch of beta testers that we mentioned. Then we decided that being a part of Onshape is fantastic, but that's not really the identity we need to have and we want to have. So we moved also outside Onshape on a standalone application that runs on any browser.
Yep.
And then we also created a new version that runs on mobile applications, tablets. We implemented all of the gestures that you need to have to work with the pinch and zoom and all of that. So all of these steps were a lot of work. As Tassos said, it took a little more time maybe than what we had anticipated. But we're at a point now where we're very happy with the product, and it's out there. It's been used constantly, and
cool. There was a lot of there is always a lot of educational material and instructional videos and models, and working with designers to build models to both demonstrate and also put out there as marketing material. And lots of times we had to go through several iterations. And as Stephanos said, yes, this took a long time, but we believed a lot in what we're doing, and we were lucky also to have Big Pie show such faith in us and believe in this deep tech endeavor to support it with those 2 rounds and to bring us in where we are now. And it's a great place to be.
Right. So you managed to do a lot with the investment from Big Pie. That's very positive. So now you're also fundraising with crowdfunding. So you said that you have the product, it's running, it's you feel that it's ready to go out there a little bit more. So I assume that's one of the main reasons you are raising capital from crowdfunding is the go-to-market.
Right.
Absolutely. Absolutely. Yes. I mean, product development never stops because it has to for the reasons we're discussing. But the core of this, the use of funds now is going to be the commercialization and marketing. And this is what we need to do.
The sales and traction now. It's time. It's time.
Yeah, absolutely. Okay. If we had room here to have Kyriakos, our CRO, in here, he would be very excited to tell you about all this. But it's definitely the number one priority.
Nice. We feel that part of the commercial plan will also be driven by the product itself. So, for example, we also have plans to enhance our collaboration capabilities, to give an example. And we feel that this will allow users to share more broadly their designs with other partners, clients. And this will also bring these new people into our platform. So we are thinking of various ways, apart from all of the, let's say, standard activities, more additionally product-led growth tactics that we are...
Again, like Figma, for example. And
so in terms of further fundraising rounds, do you have like any thoughts, any plans for the future in terms of like size and timing of these fundraising rounds? What are the thoughts at the moment?
Yes, we're still pre-Series A, and we are aiming to raise now 500 to 750,000. And then down the line, probably 18 months from this fundraise, to have a Series A round.
Okay.
The sum to be determined, but I expect it's going to be something of the order of 4 million.
All right. Okay. So I think we've said enough. We've said a lot. Just
Sorry, we talk too much.
No. It's good. It's good. So just to recap, like the $1 million question.
Yeah.
So why should investors now feel confident about investing in a company like Phi?
They'd be crazy not to. After all we've said.
Yeah.
No, seriously, I think it's a great time for what we're doing. I think we are. The timing is great because we have a team, a great team that knows what it's doing, and we've been in the field for so long, and we've put this experience and all the past mistakes into good use, and we've always had our pulse from the beginning on what the customer needed, what the industry needed, not on some random academic work, as I was saying before. And we went through the very difficult hurdle of doing the tech, right? And now we're at a position where we have the product that does what we wanted to do in a market that's growing, and in a market in which the demand for freeform modeling is also growing a lot. Not just because those aesthetics in product design were always very appealing, and now even more so because it's becoming trendy, but also because of manufacturing evolutions that have allowed lots of products to have more freeform. So it's a great time. It's great timing too for the market.
All right.
So I think it's a great team and a great idea, and a market that's expanding and ready for it.
Yeah. Sounds good.
So I hope so.
Yeah. Is there anything else that you'd like to add, like to say to potential investors, our listeners, our viewers? Anything else?
Well, I'd like to reach out. Thank you again for the opportunity, and reach out to the crowd-based investors and say that I think this is a great opportunity to. We want them to invest in Phi because it's not just the money. It's obviously that's why one fundraisers, but we're still relatively very unknown because of the stage we're at. And this will both increase our visibility. It's also happening at a great valuation. And also it will, we want them to be aligned with us in what we're trying to do, because we think that works very well. Both in terms of objectives and psychology.
You touched upon one of
everything.
the biggest benefits of crowdfunding, like having these power users that are already familiar with your product and are using it all the time. If they also invest in the company, then your incentives are perfectly aligned, and then they have even more incentive to go out there and promote the product, because they also gain financially out of this. Good stuff. So to close, where can people learn more about Phi if they want to?
They can, obviously through Crowdbase. We're happy to be listed on your page, or they can go to phi3d.com website. We have plenty of material, example cases, videos. You can learn a lot from there, and obviously reach out to us, and we'll be more than happy to chat.
So for anyone interested in using the product itself, can do so through the website. They will find a lot of resources there, I assume.
Yes.
Yeah. And then for anyone wanting to learn more about like investing into Phi, they can find a lot of information on the campaign page of Crowdbase. They can also post any questions they want on the Q&A tab of the campaign page, and they can also contact us. We are easily reachable, very transparent. So anything they want to learn more, we would address it.
Absolutely. And one final thing is that I would actually encourage people to go out and try Phi, because even if you're not a designer, some of the things...
Can I do it?
Yeah, absolutely. Yeah. In 3 minutes, you'll be up and running from whatever platform, from your tablet, from your... I wouldn't recommend it on your phone because the screens are too small, so there's not enough real estate on your screen. You could, in theory, but from your laptop, anything, you could subscribe. You have a free trial.
All right. So try it and send us your comments on how easy it is to use. Tassos just said 3 minutes. So right. So thank you very much, guys. It was a pleasure.
Thank you, Panagiotis. Pleasure is ours.
And we'll be in touch.
Of course.